Hi, my name's Amanda. I'm a PhD candidate at the University of Newcastle, and my heading is a little misleading from what's in the program, but it's still the same thing that I'm talking about. So I'm talking about the variability of the stable isotope delta 15N in seagrass ecosystems. Nope, apparently I'm not. Okay, so this isn't working? Okay. So seagrasses, we know, are sensitive to water quality alterations, nutrient loads, things from aquaculture, treated and untreated effluent, fertilisers, and so on. And we can measure seagrass abundances and so on in a number of different ways, and the impacts that it can have on the estuarine environment. So we look at presence and absence, as we've already seen this morning. We can look at aerial and satellite mapping, as we've already seen this morning. And so now I'm going to talk about stable isotope analysis, which is the main part of my actual project. So stable isotope analysis is useful for detecting and tracing biological inputs in the marine and estuarine environment. It's really, really useful after pulse events and so on, because you can see rapid changes over time and space in theory. So we measure isotopes by comparing heavy and light. So we look at heavy and light carbon and heavy and light nitrogen, and then we take what's left, and we this is really hard without my notes. The ratios are influenced by changes in productivity, where light is assimilation impacts carbon, and different nutrient sources where the things like the treated effluents and stuff can impact the nitrogen value. So on here you can see that this actually works, yay. On this chart here you can see that as the values change and the trophic level increases, you can see that the natural background levels are increasing for each value. And so I wanted to look at this for seagrass because it generally sits down here. And then the background values for seagrass, it's hard to find something consistent between paper to paper, system to system. So I wanted to apply it to where my research is. So in estuaries, this is a fairly standard, when you find a developed estuary, it's, these are a lot of the things that you'll find are influencing what's going on in there. And when there's a lot of development, it's really easy to find one that's ticking off all of these influences here like a bingo card. So this brings me to this estuary here, which is called Lake Macquarie, on the New South Wales coastline between Sydney and Newcastle. It has all of these influences here. There's sewage treatment plants, there's coal mines, there's an old aluminium smelter, there's a couple of power plants, a relatively small entrance channel in comparison to the size of the lake. We have a moderately developed shoreline and a really large catchment. There are a few spots around the lake that are still really natural. So we wanted to identify the source points for nitrogen and then to determine whether or not rainfall was contributing to the temporal variability of the nitrogen in the lake. So to do that, we needed to find enough spaces around the lake that were going to be representative of everything that was going on. So I ended up with 34 sites because there's a heck of a lot of subcatchments around the lake. you'll see see them later on if it shows up properly. It's a bit fuzzy. But yeah, so you've got up in this up north of here is where the old smelters and things are. The power stations are down here, the agriculture, sewage treatment plants, natural areas, another power station, and just lots of housing and so on, overflow points, and things going on around the lake. So here, what I did first was, with my rather large data set, I pulled the means for the seasons to get a value for the lake, and I grabbed the rainfall data from the Bureau of Meteorology website for the rainfall for the full year. And what I did was, at the 5, 10, 15 and 20 day intervals for each sampling day in the season, I've ran a correlation to see if rainfall was influencing the seagrass values. So bearing in mind that seagrass turnover rates are a bit longer than 5 and 10 days, it's not surprising that I didn't get a correlation. It's a bit more surprising that there's no relationship here, but again, this kind of just highlights that it's a big lake, it's a really broad scale, and in each of these data points, there's 34 sites and over 100 individual values. So I'm just going to blow one of them up for you and unpack it, as we say. So we'll look at spring, and this is the variability for carbon and nitrogen for spring in the lake. So the red dot is that mean from before. But as you can see, like, it's travelling along the marine to going towards terrestrial values, and then up into from depleted to enriched. So we've got the nitrogen here and the carbon there. Generally, if I'd put the site labels on there and shown you season to season, you'd be seeing there's fairly usual suspects appearing down here and over here all the time, but a lot of them cluster around in there, moving around depending on what the season is, and it does travel back and forth along the axis a bit. So, because I didn't get the correlation, but we know that there's a lot of variability going on in the lake, I generated for 4 of the seasons, so I've got a spring, a summer, an autumn and a winter, and to look at the 34 sites and the values between the seasons. So you can see, I kind of want to go over there and point at it. The sites where I thought nothing was going to happen because there's no sewage treatment plant, there's no overflow point, there's no dirty old pipe that's broken and going into the system. There's just, you think there's just a playground there, it's going to be nice. Where is he? There's a depleted value for one of them, this one here. So there's some kind of raw effluent of some kind at the kids' playground, and the seagrass meadow there is absolutely amazing though. Like, it's something really special to look at. Another one that I thought would be not really changing at all over time was this site here, and it's one of the most variable, with the values going from about 1 up to 8 or 9, I think was the highest for that one. This one over here is no real surprise. There's a sewage treatment plant leaking its infrastructure into the creek nearby. But the good thing about that result is that now the water management company knows about it. So this one was expected, I guess, yep. And then down here is another one of the reference points. It's just surrounded by national park, so the values there are fairly well, yeah, like I said, they were expected. So I've gone in closer, so there's the variability on the broad scale. I've run the rainfall again at the site scale. So this was that bay down in the bottom, Crangan Bay, and there's still no relationship between seagrass 15N and rainfall at that short scale, site scale. And over here, this one's a bit messier, but there's 4 sites in that bay that I've picked at. You can see that up in here, there's a heck of a lot more variability. Did I even say heck? That's not science, Amanda. Yeah, there's a lot more variability in here. The seagrass up here is not as nice either. Like it's pretty, the epiphyte load's always really big, the blades are really short, it's water's usually pretty turbid. Yeah, so there's no relationship between rainfall and the nitrogen value there either. So, moving on. What I found through sorting through this data is that rainfall's not influencing the nitrogen values in the lake on a broad seasonal scale, and that there are other stresses influencing the nitrogen, and I probably have that data. It's a pretty big data set and it's taking a while to get through. So you definitely can't apply a large spatial scale analysis to this ecosystem. The lake's just too big. Even when you pull out the bay and just analyse the bay, it still seems to be something that's not really working very well, because there are differences temporally within a site, but when you look at the whole lake, it's not picking it up because it's just flattening out the values too much. So because of the variations in the heat maps that I made, we can see and tell that the management and stakeholders to consider a sub-catchment based approach to maintaining the ecosystem health for the seagrass in Lake Macquarie. Okay, so that's pretty much me done. Thank you to everyone for coming and sitting here and listening to me fumble at the beginning. I appreciate it. And yeah, so that's what's next for me. I've got an awful lot of work to do. But yes, I'm very happy to have been here. So thank you. I can run away now. Oh no, I can't.
Okay, we've got time for a couple of questions if anybody's got any. Yep.
Hi Amanda, nice talk. I'm just wondering if you can say a little bit more about the circulation and what the hydrodynamics are within the lake and how this might affect things, yeah.